Assalamualaikum and peace be upon you. I am Khairul Afiq bin Baharin and this is my partner.
Assalamualaikum, my name is Nuqman bin Tukimin.
We are from group T13 of the big group J4EE11121A1. This is our video on our mini project in Electro-Technology, code EEE111. So we will break this into two parts. Part 1 will be the introduction and the use of simulation software, and part 2 will be on the printed circuit board, also known as the PCB, fabrications and components assembly.
Starting with part 1, the objectives are to understand the basic concept of simulation and circuit design using Pro Tools Design Suite software, and introducing the fundamentals of Pro Tools Design Suite software to be used in DC analysis. Pro Tools Design Suite software is an electronic design automation (EDA) tools consisting of schematic capture, simulation, and printed circuit board modules. It is mainly used for designing, simulation, and analyzing analog, digital, and mixed electronic circuits. Here, we have broken down to 3 more parts, namely Part A, Part B, and Part C, which is our first part of the mini project. The aim of Part A and Part B is to understand the basic concept of simulation and to introduce the Pro Tools Design Suite software. Here we can try and get to know the software so that it is easier to use while doing our first part of the mini project. Lower the risk of making a mistake and avoiding problem onwards. In Part A and Part B, we start by arranging the component in the schematic capture. Once we done arranging the components, the simulation is started, and the emitter will show the current reading in the simulation. After that, we will transfer the schematic capture to the PCB layout. Once both Part A and Part B is done, we continue with Part C. The same procedure is used. We arrange the components in the schematic capture. After we done, the circuit is then simulated. The simulation will also include the status of the LED, either it's blinking, lights up, or not functioning. Once the simulation is passes, we transfer it to the PCB layout and adjust the circuit as needed before finalizing.
Continuing with part 2, which is the second part of our mini project. The objectives are to understand the process of PCB fabrication and to know the proper tools used in PCB making. In the video, we can see the PCB fabrication process flow. Here is a brief summary on how the PCB looks after each process. You may pause the video to have a better look. Moving on, we start by cleaning the copper on the PCB surface. After that, we proceed on to the laminate process. We laminate using a dry resist film onto the PCB copper surface. It is very sensitive to light, hence why we have to stay under minimal lighting while in the process. It has 3 layers, of which 2 of them are protective layers on the top and under the bottom of the photoresist. The middle layer is what we use to laminate the board and is blue in color. It is laminated at 90 degrees Celsius. Next, we continue with UV exposure to transfer artwork onto the PCB copper surface. The time is set to 30 seconds and a vacuum is used to suck out air present. Next, we move on to the developing process with the rotor spray developer. The unexposed photoresist is removed chemically, leaving the layout in photoresist on copper. We use the developing machine at 28 degrees Celsius with conveyor speed of 4 and takes about 3 minutes. The liquid used in this process is the developer liquid. Then, the PCB goes into the etching machine for the etching process, where it washes the board with ferric chloride acid thus eating away any exposed copper. The actin has to be ensured warm enough before use. This takes about 2 minutes. Then, we move on to the photoresist stripper. This will remove all the photoresist from the edge circuit board, revealing the copper that makes the circuit on the board. Finally, acid cleaner cleans the board and designed to prepare the copper for plating. The PCB is rinsed with water and we can proceed with the drilling process. In the drilling process, we make holes on the PCB using suitable drill bits. We use 0.8mm drill bits for component holes and 1mm drill bit for connector holes. Lastly, 3mm drill bit is used for the corner fixing holes. Once drilling is done, the PCB is ready for soldering. We can finally proceed to solder components onto the board. We ensure that the board is clean before beginning soldering. After the board is clean, we clean the solder iron bit tip using a damp sponge. After a component is inserted into a hole, we apply a clean solder iron tip to the copper and the lid in order to heat both items at the same time. We continue heating while applying a few millimeters of solder. Once done, we remove the solder iron and allow the solder joint to cool naturally. This takes a second or two to make the perfect joint.
Ebbing and flowing, inhibited, limited, till it broke up when it rained down. It rained down like. Hey, get me up, believer, believer.
So this is our PCB circuit. It is connected to a DC power supply. The voltage was set to 9 volts. You can see that there are two LEDs. One is blinking, one is not. The LED that stays lights up indicates that the circuit is closed and complete. The blinking LED is blinking because of the program integrated to the circuit.
Part A, which use the produce design insert software component either in the schematic capture or the PCB layout must be arranged correctly to prevent error. In the mini project part B, we learn the process of PCB fabrication. Everything starting from laminating to soldering must be done carefully in order to fabricate a perfect PCB, as each process has effect on the PCB. On top of that, this will also prevent damage and error that might occur later. As an example, care must be taken when the railing as doing an error can damage the copper and the current may not flow. Besides that, during the soldering process, there are some precautions that have to be taken care, or else we might run into short circuiting. The lid has to be covered, the whole hole, to make sure that the circuit is fully connected and there are no hiccups. On top of that, molarity of the component has to be correct, or else it might not work.
After soldering, the board is troubleshooted to make sure that all components is working correctly. Power supply is connected to the PCB and we observe that both LEDs have trouble sustaining their intensity. On top of that, the blinking one is having trouble staying on. It is on and off, as if there are not enough current flow. Continuity tests and insulation tests were done, and we found out that when we were soldering, in the soldering process, we heated the lid a little bit too much, a little bit too long, and melted the copper on the PCB circuit. We had also melted the rubber of the jumper wires. The result of this is current is not flowing constantly and were not enough. We fixed this by melting the lid and use it to replace the missing copper on the PCB to connect them again. Once this is resolved, the blinking LED still cannot sustain its intensity and still keeps on turning off. After troubleshooting by checking the voltage supply and the voltage running on the circuit, we concluded that the LED is defective. After changing the LED blinks as it should be, and thus our PCB is successfully working. To conclude, you are able to understand the basic of the simulation and the circuit design using Protus Design software, and we will introduce to the fundamentals of the software itself to be used in DC analysis. Next, you are able to understand the process of PCB fabrication and know the proper tools used in the PCB making. We will introduce on how to fabricate and drill the PCB, and finally solder the components onto the PCB itself. The Protus Design software is very important. By conducting this experiment and doing the mini project, it introduces us to the workspace we might experience in the future, and this will help us to get ready to become an engineer.
So as a result, the objective of the experiment is achieved.
This mini project is a success.
And
Thank you and Assalamualaikum.
I'm a puppet on a string, Tracy Island, time traveling diamond, could a sheep heart